Okay, so this is question number 4 on exam 2. Two objects are connected by a light string that passes over a pulley, as shown in the sketch below. The surface and the pulley are frictionless. Mass 1 is equal to 8.00 kilograms, and mass 2 is equal to 3.00 kilograms. In part A, we're asked to draw a free body diagram for each object, breaking up all the forces so that they are either in the direction of the motion or perpendicular to the direction of the motion. So first, we'll do a free body diagram for mass 1. So this is the x direction, and this is the y direction. And we have a tension force acting up the incline, and we have the x component of the weight of mass 1 acting in the minus x direction. And then in the perpendicular direction, we have the normal force acting the plus y and m1g cosine theta acting in the minus y. Okay, so that's mass 1. Now let's do mass 2. Well, its motion is only in the y direction. It has the tension acting up and m2g acting down. All right, so that's all there is to part A. In part B, find the magnitude and direction of the acceleration of each object. So we want the magnitude and direction of each acceleration. Well, we know that since the two masses are connected by a common string, then they're going to feel a common tension. And the result is that each will have a magnitude of acceleration that's the same. But whatever direction the acceleration of body 1 is, the body 2's acceleration will be the negative of that. That is, if body 1 goes up the incline, then body 2 will go in the negative y direction. Or if body 1 were to go down the incline, then body 1 were to go up the incline. So that's an acceleration constraint in this problem. So now let's sum the forces acting on body 1, summing the forces in the x direction on body 1. So we have the tension force in the plus x direction and m1g sine theta in the minus x direction, and that's equal to m1 times a1. Then if we study the motion of mass 2, some of the forces in the y direction has the tension in the plus y direction and the weight in the minus y direction, and that's equal to mass 2 times a2. But as we said before, A2 is equal to minus A1. So we could write this as minus M2 times A1. And then just solve for A1. So if I call the first equation, equation 1, and the second equation, equation 2, and then subtract equation 2 from equation 1, then the tension terms will drop out. So that's what I'm going to do. And when I do that, I get minus M1G sine theta plus M2G is equal to M1A plus M2A. I'll call it A1. Factoring out the A1, I have that's equal to M1 plus M2 times A1. Then if I solve for A1, that's equal to minus M1G sine theta plus M2G over M1 plus M2. And then if we put in the numbers, we have minus M1, which is 8 kilograms, times 9.8 meters per second squared times the sine of the angle. Let's see, the angle was 25 degrees. And I've shifted this down a line so I have more room to write it all. Plus M2, which is, what do we say? 3.00 kilograms. Times G. And then we divide that by 8.00 plus 3.00 kilograms. Okay. And we see that there's kilograms in each term in the numerator and there's kilograms in the denominator. So the kilograms are going to cancel out. And we end up with units of meters per second squared. And when we put these numbers in our calculator, we see that the answer is A1 is equal to minus 0.339 meters per second squared. Let me make that a little neater. So that tells us that body 1 is moving in the minus x direction. And A2 is equal to plus that. So it moves in the plus y direction. So that's the magnitude and direction of each acceleration. So that's part B. And then part C. Solve for the tension. Well, I can use either equation 1 or I can use equation 2. I'm going to use equation 2 since I don't have to use the sign. So 2 tells me that T minus m2g is equal to m2a2. So T is equal to m2 times g plus a2. And m2 is 3.00 kilograms. And G plus A is, I'm sorry, that's wrong. Let me erase that. No, that's right. And G is 9.8, and A2 is 0.339 meters per second squared. So the tension is 30.4. And that concludes this video.